Welcome back. Now let's see one of the most indispensable prototyping component, which is called breadboard. Okay, breadboard. Okay, the image that you are seeing here is of breadboard that we are going to use throughout this section of the course. Okay, now you must be wondering what the hell is breadboard and why would one use it in first place, right? Isn't it? Why we use breadboard? Well, first and foremost, it's solderless, which means you don't require any soldering to make a prototype. Now, why I'm mentioning the soldering? Because electronic prototyping is all about creating some output using electronic components. The process requires that all the components are connected exactly as shown in the schematic diagram, the diagram that you make before assembling everything. Okay, before making your physical assembly, or say. Now, this is typically achieved by fabricating all the components on a PCB, printed circuit board. Well, if you have a breadboard at hand, you don't need to do so. If as far as the prototyping is concerned, you don't need to do so. Okay, you don't need to fabricate a PCB just for the sake of prototyping. The second advantage is that it is incredibly easy to make or break the circuit, or connect or disconnect the components, which means you can use the same breadboard for multiple projects, which is kind of cool, right? Yeah. So all in all, it's all about the simplicity. So it's very simple to use. Okay. Now, the breadboard is always used to make temporary circuit connections. Okay, which means, I mean, you just make a connection, you just test it and disassemble everything. So it's temporary. You can use the same breadboard for multiple projects, as I just said. Okay. Generally, what happens that let's say if you have some idea and you want to create a device, and for that you want to create a PCB, right? Now, before making that PCB, you might just want to test the circuit, which you do using a breadboard. So breadboards are extensively used for testing purposes. Once your test has been conducted fully, then you are ready to move on to the permanent solution like PCB and all. Okay. All right. So now that you know what the breadboards are capable of, let's see what goes inside a breadboard. Okay. The section A and section D are both power buses. These are called power buses. Okay. Section D. This is also power bus. Okay. As you can see, both these buses are horizontally connected with each other, right? They are separated. Blue and red are separated, but the blue and red both are horizontally connected, right? Horizontally connected. Now this blue line at the top, let me just, this blue line at the bottom and the top, this is a ground. This is ground, okay, or the negative bus. This is the ground bus or negative bus. So ground could also be called as negative bus. Some people call it ground, some people call it negative, but ground is the standard practice. This is also ground. And this red bus is a positive bus. Okay, and this is given there both top and bottom. This is the positive bus. The positive supply of the battery goes here. Okay, top and bottom both. You have two power buses, one at the top and another at the bottom. Okay. Now the purpose of these buses is to extend the positive and negative supplies to the entire board. Okay, just like this, just like these drop links. So 5 volt, 5 volt, 5 volt. Similarly, the ground. So if you want to extend the 5 volt and ground supplies, you need to charge the buses first. Now, important thing to notice here is that if you apply the voltage or the positive supply across any one hole, because these buses are horizontally connected, the entire bus charges. So you don't need to apply the power at each hole. just one hole is sufficient, right? So if you want to extend the power to, let's say, somewhere in this board, okay, you can take any tapping from anywhere from the bus, but you need to connect just one wire from your battery to your bus. So that's just as so, okay. And the same holds true for the negative bus as well. So you need to connect the negative on any one point on the bus, and then you can take any dropping from any point and extend the power or ground to any section. Okay. Now the standard practice is that if you want to connect any component on section C, you should take the power from the section D. Okay, power and ground both you should tap from section D, and likewise for section A and B, right? If you want to connect any component on section B of the breadboard, you should take a droppings, or you should take a tapping from section A. This is important. This is a standard practice. Now you can do otherwise as well, but this is a good practice to do that in order to avoid any confusion. Okay. Okay. Now these labels, as you see here, these are just to suggest that which is the power bus and which is a negative or ground bus. Now this is not a standard. There are some breadboards where you might find this labeling, and there are some where you cannot. Now if you see the positive, you are supposed to connect a positive bus bar, and if you see negative, it should be a negative bus, right? But that's not a standard case. There are breadboards where you don't see the positive and negative labeling, and just it could be just plain. So you can, but one thing which is going to be sure is that the first section, the section A and section D, are going to be dedicated bus bar section, right? But the positive and negative sequence, this could interchange, no big deal. So you can connect the positive supply in your blue section as well, and the ground at the red as well. So there's no hardcore kind of requirement, right? It could be interchanged, so just be aware of that. The only thing that you should remember, that the section A and D in any breadboard are dedicated power bus which are horizontally connected. Now, what will happen if these buses are vertically connected, which they are not? If they are vertically connected, they would become short, right? Your positive would connect directly with your negative and your supply would be short. Okay, now let's see how the breadboard works. So this section is where you connect your components, the section B and section C. Okay, this is where you connect your components. Every component is going here. So you need to extend the positive supply or any supply, you take a tapping from your bus. Now these points are vertically connected and not horizontally connected. What do I mean by that? So if you connect anything on, now this is all the very same for this section as well. Now these points are vertically connected, okay? Vertically connected means if you connect something here on point number X, you cannot connect it on point number Y, because X and Y are short, right? Because they are vertically connected, right? Remember I told it to you just now. They are short to each other. These two sections are not connected at all. Not connected at all. So there's a break between them, okay? Now the breadboard is always divided in two parts. Let's say this is my side A and this is my side B. Side A and side B. And they're always separated by a break in between, right at the middle of the breadboard, just like this here. Okay. Let's see how this gap is useful for prototyping. Okay. Now on the image you have two switches. One is at left, another one is at right. You also have an IC or integrated circuit. Well, here is this microcontroller, but this is also an integrated circuit, right? Now these components are firmly placed in the gap. provided on the breadboard, right? Now these are meant to be so, and this is why this gap is useful, because this provides an isolation, right? Because you cannot short your IC. If you place your IC somewhere in the prototyping area, this would short your IC, which is not desired, right? Likewise for the switches, because switches are meant to break or make the circuit. So the switch has to be separated, right? Okay. Okay, so let me quickly summarize everything about the breadboard that we have learned so far. The power buses section A and section D, these are always horizontally connected, right? These are the horizontally connected buses, and if you apply the power or ground to just 1 volt, this would distribute to the entire bus. That's one. The holes in the prototyping area are vertically connected. So what you connect at one point, if you connect a component at one point, you cannot connect anything else on the entire leg. Okay, so that's second. And every breadboard is separated in two parts, part A, part B, and is separated by a gap. Okay, so this gap is very useful for placing essential electronic components such as IC and switches. So yeah, so that's about it. So that's all about our breadboard. Okay.